All right, number 11 here. We have some complex numbers. Probably one of the most important things right out of the gate to realize is it is true that I equals the square root of negative 1, but it's probably more important to know what I squared equals. I squared is just when you take the square root of negative 1 and you square it or multiply it by itself. And actually, you know, squared and square root those are inverses of each other. They're opposites. So basically they cancel each other out. So when you square it, you just end up with a negative 1. So that's probably the most important thing I'd like you to remember, is that I squared equals negative 1. I think that's going to be very helpful. All right, so let's kind of go through and look at this. Well, we start off with 3 minus 5i and over 8 plus 2i. And you're not allowed to have an imaginary number in the denominator. So how we take care of that is we basically multiply by what's called the conjugate. And you basically rewrite the bottom phrase, but with the opposite sign. So since this was a plus, I'm going to put a minus over there. And I'm going to do the same thing on the bottom. So I'm multiplying by what's called his conjugate. And I'll show you what's going to happen. You're going to multiply the top together. And you kind of think about this just like how you do FOIL. Where you do the first times first. So, 3 times 8 is 24. 3 times negative 2i, well, that's negative 6i. Negative 5i times the 8, that's negative 40i. And negative 5i times a positive 2, or negative 2i, gives me positive 10i squared, which we're going to substitute here in a second. On the bottom, this is a little bit more interesting. On the bottom, when I do my FOIL, I get 8 times 8, which is 64. And then when I do the inside and the outside, on the outside I get negative 16i. On the inside I get positive 16i, which those guys are going to cancel out for me. And that's why I chose to do the difference of squares here, because the inside term cancels. And then when I do my last times my last, I get minus 4i squared. So I'm going to clean things up a little bit. Up here on the top, I'm going to gather up these like terms. So I'm going to have 24 minus 46i, and then plus, and instead of writing 10i squared, I now know that I squared is just negative 1. So I'm going to substitute that in there and eliminate that I squared part. And then also on the bottom, I'm going to have 64, take away 4, and instead of writing I squared, I'm going to put negative 1 in again. So I'll kind of come over this way because we're running out of room. On the top, I'm now going to have, I have 24 plus a negative 10. So that comes out to be 14. So I'm going to have 14 minus 46i all over, that's 64, take away a negative 4. So 60 away, take away a negative 4, that's 68. All right, so I look at my answers, and unfortunately I don't see any of them there. But I do realize that these are all even numbers. So if I divide everybody by 2, I'm going to get 7, take away 23i, all over 34. Which another way to write that is to just break up the two pieces and divide them separately. 7 divided by 34, take away 23i divided by 34. Those two are equivalent to each other. And so I find out the correct answer is C. So I wish I had a shorter trick, but that was a little bit messy. But the key, the whole part to doing that entire problem is knowing that I squared equals negative 1. So definitely put that in your toolbox. All right, number 12, website's formula, calculating the rating, favorable views, unfavorable. Basically, we need to rewrite this expression in terms of F. Right now it's solved for R, so we want to do it in terms of F. So let's see what we can do here. We start off with, this is our original equation, so I'm going to rewrite that. We have R equals F over N plus F. And to clear that fraction, or to get rid of that, I'm going to multiply this expression by the other side. So I'm going to times that over here by N plus F. Technically, I'm multiplying both sides by N plus F, but these dudes are just going to cancel. Divide and times wipe each other out. So I'm going to get F equals, and now I'm going to need to do a little bit of distributing here. So R times N times R times F. So I'm going to have Rn plus Rf f equals f. And I still don't have f all by itself. So I'm going to move this to the other side. I'm going to subtract this rf term to try to get the f's over on the same side. And when I do that, this goes away, and I'm left with Rn equals f, take away Rf. And now I recognize that those two terms both have an f in them. So I can pull out a factor of f. It's kind of like the reverse distributive property. So f times what will give me f? Well, that'll be a 1. And then f times what will give me a negative Rf? That will be a negative R. And I have Rn still chilling over here on the other side. And now finally, to get f all alone, I need to divide both sides by 1 minus r. And divide this side by 1 minus r. And this will cancel out. And finally, I have f all alone, and I get my answer of Rn over 1 minus r. So the correct answer there would be B. No real nice shortcuts, which I have one on this one, but I don't. All right, number 13. What is the sum of all values of m that satisfy? So a couple things to this question. Number one is I have to find out what m is, but then I have to add the two answers because I see this as a quadratic. I see this squared right here. So I know this problem has two zeros or two correct answers, and I'm going to then add them together at the very end to get the final answer. So first thing I notice is this quadratic, everybody can be divided by 2. So I break that down. I get m squared minus 8m plus 4 equals 0. Well, typically when I have a quadratic, I set it equal to 0, and then I go ahead and I try to factor it out. I try to figure out two factors. And I'm trying to come up with two numbers that multiply together to make 4. But my only options are either 4 and 1 and 2 and 2. And no matter how I put those 4 and 1 and 2 and 2, I don't see how my terms are going to add up to be this negative 8 here. So right away I'm like, crap, I don't think I'm going to be able to factor this. I'm going to have to bust out what's called the quadratic formula. Unfortunately, they don't give you this, so you're going to have it memorized. So the quadratic formula is negative b plus or minus the square root of, and you may remember this from algebra or advanced algebra, algebra 2, minus 4ac all over 2 times a. And I got to tell you what the a's, b's, and c's are. So in this equation, the a is always the number that's in front of the squared term. So in our equation here, a equals 1. B is always what's in front of the m. So b is negative 8. And then c is always the back number. That's called standard form for a quadratic. A's in front, b's in the middle, c's at the end. So I now have to plug and chug and basically stick all these numbers in here, which isn't really fun, but let's get after it. So I have negative b, which is negative 8. So a negative 8 is really just positive 8. Plus or minus the square root of, and be careful here, b squared, don't just punch in your calculator negative 8 squared, because it'll tell you the answer is negative 64, but that's not what they're saying. They're saying negative 8 squared means do negative 8 multiplied by itself, which is positive 64, minus 4 times a, which is 1, times c, which is 4, all over 2a, or 2 times 1. So we clean this up a little bit. I'm going to kind of jump, way over here where I got some more space. So we have 8 plus or minus the square root of, that's 64 take away 16. 64 take away 16 is 48. And that's all over 2. So again, none of those answers are really looking what I need. I think what they did here, it looks like they probably simplified this radical. There's a couple different ways to simplify this radical, but I'm going to show you kind of a cool way that I've used over the years with my students, and they've gotten better using this method. If you remember how to do prime factorization, you can do it this way. So basically you take the number 48 and you think of any two numbers you can think of that make 48. Like for instance, first thing that pops into my head are 6 times 8. But you could have used 3 and 16, 2 and 24. You can use whatever you want. That's what I like about this method. Then you keep going, and you break down 6 is 2 times 3, and they're done. You can't go any lower. 8 would be 2 times 4, and then 4 would be 2 times 2. Now, at the end of all this, what you have to remember when you're simplifying radicals are every pair counts once. So a pair of 2's counts once. Another pair of 2's counts once. That makes your outside number. And then whatever your loner is, this 3 is a loner. He doesn't have a pair. Whatever your loner is, you slap that underneath the radical. So now I have 4 radical 3. So I'm going to clean this up a little bit up here. This is 8 plus or minus 4 radical 3, all divided by 2. And now when we divide that out, when I do the 8 divided by 2, I get 4, and plus or minus. And then when I do the 4 divided by 2, I get 2 radical 3. And here's kind of where things get a little bit interesting. So I have 2 answers now. I have 4 plus 2 radical 3. That's one answer. And then I have 4 minus 2 radical 3. Well, the original question said, hey, what's the sum of the 2 answers? So my 2 answers now, when I add them together, something kind of nice happens. This plus 2 radical 3 and this minus 2 radical 3, they squash each other. They're gone. So ultimately, I'm just left with 4 plus 4 equals 8. So the correct answer finally is D, 8. I want to kind of show you another way to simplify this radical. If you kind of didn't really follow what I did down here, you may have done something in school a little bit different. So let me show you that way. So if you want to simplify the square root of 48, you could also look for perfect squares. Perfect squares are square roots that come out to be a nice whole number. And these are like some of the perfect squares here that might be helpful for you. And I could keep on going all the way down. But if you can find a perfect square that goes into 48, you could also break it down that way. So I realized like the square root of 16 times the square root of 3 also makes the square root of 48. And then the square root of 16 is just 4. And then the radical 3 kind of comes along for a ride. So that's another way to simplify radicals. But kind of over the years, I've kind of learned that I like the prime factorization way a little bit better. All right, number 14, radioactive substance decay. So right there, those words, radioactive decay, kind of, I got to know what that's talking about. Decay means that it's decreasing by a certain percent. So whenever you're talking about a percent increasing or decreasing, there's kind of a general formula. You have your starting amount or your initial amount. And then, depending on if you're growing or coming down, if you're growing, you go 1 plus the percentage as a decimal. And if you're losing value, you're going to go 1 minus the percent as a decimal. So if I'm losing 13% per year, that means I'm going to go 1 minus 0.13. Or really, I now have 87% of what I had before. So our starting amount for this one is 325. So just kind of knowing the structure there, that wipes out B, and that wipes out, that wipes out all of them. All right. So basically that's all you really had to know. Then the T up here is really how many times that happened, how many time frames, whether it's years or days or whatever. But this formula here about the starting amount and then decreasing, you go -1. If you're increasing, you add to 1. That's huge. That shows up a lot on this test. All right, number 15, the expression 5x minus 2 over x plus 3 is equal or equivalent to who? There's an algebra way to do this problem, and I'm not going to take you through it because it's long and it's going to waste a lot of time, which is what they want you to do. This type of problem, so many times when it says something is equivalent to something, I'm just going to pick a number and plug it in. I'm going to pick the number. I usually try to pick like 2 or 3. I'm going to pick the number 2. So let's go x equals 2. And when I plug that in, I get 5 times 2 minus 2. Well, that's 8. And then on bottom, I got 2 plus 3 is 5. So we're looking for the number 8 over 5. And we let x equal 2. So we kind of go through the answers here, and let's see what shakes out. The first one is 5 minus 2, which is 3 over 3. Well, that came out to be 1. That doesn't match my answer. The next one, 5 minus 2/3. Well, that would be 4 and 1/3. Or 4 times 3 is 12 plus 1, 13/3. That doesn't check out with me. Let's try this next one. 5 minus 2 over, and then x, remember we let x equal 2. So that would be 5 minus 2/5, which that would be 4 and 3/5. Or changing it to improper, 4 times 5 is 20 plus 3. That would be 23/5. Uh-oh. Hopefully this last one here works. I have 5. Take away 17 over 2 plus 3. Or 5 minus 17/5. And that's really, I could do it a couple ways, but I'm going to call 5 25/5 minus 17/5. And hey, what do you know? We get our answer of 8/5. So the correct answer for that one is D. I did not go through a lot of nasty algebra to get that. I simply picked the number, plugged it in, put it in the answers, made it match mine, and we'll call it a day. All right, number 16, free response. Sales manager of company is awarded $3,000 in bonuses to the most productive people. The bonuses could only be in amounts of $250 or $750. So that's it. So let me first starting to get a lot of information here. I'm going to just jot some things down. So we have $3,000 to spend in bonuses. And the only types of amounts can be either $250 or $750. There's no other bonus size that it could be. If at least one person was given $250 and at least one person was given $750, so meaning that they weren't all $250 or they weren't all $750, what is one possible number of $250 bonuses awarded? Well, let's just kind of try this out. So, is it possible to only give one $250 bonus? So actually, let's start with the $750. That's a bigger number. That might be easier. So if we start with the $750 bonus, well, if we do $750 times one person, that would be $750, and that would leave us, $3,000 take away $750. That would leave us $2,250. And which means that if we look at bonuses there, $2,250 to go into, or $250 to go into $2,250, that would be 4, 8, that'd be 9 of them. So it looks like in this one we had 9 $250 bonuses and 1 $750. Well, we could go, the question says, what is one possible number? So it looks like 9. We could be done right now. 9 is a possible number. I'm going to keep going. Let's say that there were 2 of these $750 bonuses. So if there are 2 of them, that would be $1,500 used up. So now we would have 3,000 minus 1,500. We would have $1,500 left. And so how many 250 bonuses would go into 1,500? Well, 4 is 1,000 plus 2 more. So it looks like there could be 6 $250 bonuses. So that could have been a right answer. If 3 people got 750, that would be 750, 750 is 1,500 plus another 750. We'd be at 2,250. And that would leave us left over $750, which means 3 people could get 250. Now, if you go any further, I'm going to put this in red, because if you go 750 times 4, you've wiped out all $3,000, and it said we had to have at least one 250. So I couldn't go this scenario. So looks like any of these 3 numbers here would work. Now you don't want to put all of them. You want to just, as soon as you get one, put it in. All right, 17, we have an expression. It looks like we're multiplying some monomials with binomials. And then we have this general form. This is a general form of a quadratic over here, ax squared plus bx plus c. But it says in the equation above, a, b, and c are constants. They're just numbers. If the equation is true for all x's, what is the value of b? So basically, they want me to tell you at the end of all this what number is sitting in front of x. So let's work on this left-hand side here. Let's distribute and get rid of some parentheses. So 2x times 3x is 6x squared. 2x times the 5, that's plus 10x. Then we have a positive 3 times 3x, which would be 9x. Then we have a positive 3 times 5, which is 15. Now we can clean this up a little bit. We have 6x squared. We can combine these two like terms to make 19x plus 15. And now it becomes clear who the b is. The number in front of x is positive 19. So that would be your answer for number 17. All right, number 18. Looks like we have a couple triangles there, a few dimensions. In the figure above, segment AE, and then you got to know what this symbol right here means. This symbol right there means parallel. And that becomes important here in a second. So AE is parallel to CD, and segment AD intersects at B, which you can kind of see that. They cross right there at point B. What is the length of CE? So ultimately, what we're trying to figure out is we want the length all the way from C all the way down here to E. Now I know it's bigger than 8 because just this piece right here is 8. We have a 10 over here, we have a 5 right there. Well, here's the key to this problem. Whenever you have parallel lines, let me just kind of quickly review. When you have two parallel lines and you have what's called a transversal cutting through them, you have a bunch of angles that are equal to each other. But most importantly, and the one that's tested the most, is this angle right here between the transversal and the parallel line and this angle here. Those are called alternate interior. Alternate interior angles. Now the name's not that important, but it's important to know that they're equal to each other, because up here in this problem, you know, see how there's kind of like a Z here, like this line comes, it comes down, and it goes back, and it forms like that Z. Well, we kind of have that Z going on up here, where we have this angle is going to equal this angle, and then this angle is going to equal that angle. And if you remember from geometry, if two triangles have two angles that are congruent, that means they're similar to each other, meaning that like one is a big brother kind of the other one. So, and I also have these vertical angles here. You know, that's got to equal this one too. So now it's just a matter of who goes with who, and the two triangles are similar. So I look at this side, this 5, that's hooked to the 2 and the 3 arc. Well, down here is the 2 and the 3 arc, so it looks like this 5 got blown up to be 10. So it looks like everything is a multiply by 2. We call that a scale factor. We have a scale factor of 2. So, you know, you might be able to just do this in your head. So what number got blown up to make an 8 by multiplying by 2? Well, that would make this piece 4. So now the final question is, how far is it from C all the way down to E? Well, it's 4 plus 8 is going to give you a grand total of 12 to answer this question. Now, if you wanted to get a little bit more formal and you didn't really see what was going on, we could call this X, and we could have used a proportion, and we could have used a pair of corresponding sides. So we could have said 5 is to 10. So 5 is to 10 as, and if you're going to go little triangle over big triangle, then you'd have to go little triangle side over big triangle side. And then you could have actually cross multiplied and got 10x equals 40 and divide and get x equals 4. But a lot of times they pick nice friendly numbers that you can just double or triple and get the right answer. All right, number 19 says in the xy plane above, 0 is the center of the circle. The measure of angle AOB is pi over a radians. So radians, remember, are just another unit instead of degrees. You know, kind of like there's inches and then there's centimeters. Well, degrees and radians are two different ways to measure angles. You're really going to have some trigonometry background or some pretty advanced geometry background to do number 19. There's no way to kind of sneak this problem. So I'm going to show you a way or two that you could do, but either way would be you'd have to have some higher knowledge. So first, remember this ordered pair. This is an X and this is a Y. And X represents the distance here, and y represents the distance there. So in effect, I basically have a little triangle that has a 1 height by a radical 3 base. So if I come over here, you know, because I'm pretty familiar with geometry and trigonometry, I teach it a lot, I automatically saw a special ratio. And if you could remember this special ratio, that in a 30, 60, 90, if that's 30 degrees, you know, this is 60 degrees. The 30, 60, 90 has a special ratio where the smallest leg, the side opposite the 30, is always half of the hypotenuse, which would be 2. And then the longer leg is always radical 3. So that's just kind of a ratio that I have memorized. So when I saw this problem, right away, I knew that this was a 30-degree angle in here. And then you need to know how to convert radians to degrees. So the big idea to remember with radians to degrees is 180 degrees equals pi radians. That's a conversion that you need to use. So I'm trying to figure out x over what radians. I know the degrees. The degrees are 30. So I'm going to start like this. I know it's 30 degrees. I'm going to multiply by a conversion, kind of like you do in science. And if I want to get rid of degrees, I'm going to put my conversion with degrees on the bottom so that they cancel out. So we know that pi is the same thing as 180 degrees. This is really like 1 over here. I'm just multiplying by 1. But what happens is when I cancel my degrees out, I multiply and I cancel my degrees out, I get 30 pi over 180, which I'm going to knock off the zeros there. I got 3 over 18, which really comes down to 1 pi over 6. And they're saying, hey, it's pi over a. So if it's pi over a, the a they're looking for is just the number 6. So the value of a is 6 in this one. So that's one way to do it, if you remembered the special right triangle ratio. If you did not memorize the special right triangle ratio, you could use some trigonometry on this one. You still have to kind of think about this triangle, you know, being radical 3 and being 1. And we're trying to find this angle here, which I'm going to call theta. And if you remember from trig, you know, if my reference angle is theta, if I'm kind of standing over here and that's my reference angle, this would be the opposite leg and this would be the adjacent leg. And you could use Pythagorean theorem if you wanted to maybe try to get the hypotenuse, because I don't really know any sine values that involve 1 and radical 3. So you could have did Pythagorean theorem and maybe said, well, 1 squared plus radical 3 squared equals what squared? And you get 1 plus 3 equals c squared, or c squared equals 4. And then when you take the square root of both sides, you'll see that c equals 2. So you might have ended up with that same ratio that I knew earlier. Well, now the tough part, though, is you're going to have to at least have a couple of the sine or cosine things memorized, which not a lot of people do. But right now, I'm going to kind of get rid of this to give myself some room. Right now, if I wanted, like I have the sine of 30 memorized. I don't know why, but I had a teacher that we had to memorize the sine of 30 was 1/2. So the sine of 30 would be opposite over hypotenuse, which in my problem up here is just 1/2. And, well, actually, I didn't know it was 30. We can kind of say the sine of theta. But once I see the 1/2, I'm like, oh, yeah, I remember that the sine of 30 is 1/2. I don't know. Either way, you got to have some knowledge about either special right triangles or you have to have that sine of 30 memorized to do this problem. If somebody else sees a shortcut, reply in the comments and show me a shortcut that I could kind of sneak in here. All right, final problem on the no calculator is number 20. Looks like a systems of equations. Probably going to be kind of tough since it's the number 20. So let's check it out. In the system of equations above, a and b are numbers, constants. If the system has infinitely many solutions, okay, what is the value of a over b? Well, the first thing to know is when I graph two lines, You know, several things can happen. Maybe I graph two lines, and what happens usually is the first line maybe goes one way, the other line goes another way, and they have one solution, one XY pair that works for both of them. That's what happens a lot. Well, sometimes you graph the two lines, and they're parallel to each other. They never touch each other. That system has no solution. There is no ordered pair that makes them work. And then the third thing that can happen, that probably happens the least often, is I graph the two lines, and I graph the first line, and when I graph the second line, it lays right on top of itself. And so that's a situation where you have infinite solutions, okay, when they're the same line. Now, the same line happens when one equation is a multiple of another one. So for instance, if I have the equation x plus y equals 3, if I double everything and I multiply everything by 2, 2x plus 2y equals 6, these two are going to be the same exact line because one's just a multiple of the other one. So I'm going to make this top line be a multiple of the bottom. And I need to do that by multiplying by 5. I think if I multiply it by 5, we'll be in okay shape. So when I come across the top here, I'm going to have 5ax plus 5by equals 60. And now on the bottom here, I have 2x plus 8y equals 60. So right now they're almost matching, but to get them to match, I kind of have to figure out, you know, how am I going to make that 5a equal 2? So when's that going to equal 2? Well, I just got to solve for it. I'm going to divide both sides by 5, and I get a equals 2/5. And then I come over here and I'm like, well, when am I going to make b? How am I going to get that to become an 8? So 5b, when does that equal 8? We'll divide both sides by 5, and I get b equals 8/5. So now I have an a and a b that work, but the final thing that they want me to do, they want more. I got to do a divided by b. So I need to do a, which is 2/5, divided by b, which is 8/5. So I have to divide two fractions. And remember, when you divide fractions, you keep the first fraction the same. You change the multiplication, and then you flip, or you do the reciprocal of the second one. Some people say keep, change, flip. So 2/5 times 5/8, that's going to be 10 over 40, which reduces down to 1/4. All right, that was a lot of work, but correct answer there is 1/4. Now I do have another way of doing this one. I had a student show me this one time that was kind of same thing but kind of different. Where earlier I went and I multiplied this row by 5. Well, I had a student that said, well, wait a minute, why don't you just divide the bottom row by 5? And that'll give you your 12. And I was like, oh, that's pretty clever. So now right away, you can see that a equals 2/5 and b equals 8/5. And then you just do the same thing that I did before. 2/5 divided by 8/5. And you end up with 1/4. But I thought that was kind of a clever way of dividing the row instead of multiplying the other one.